Hi, I'm going to make myself a bit unpopular now with Tara and Frank's. Possibly not the best thing to do when you're announcing a new grant fund. Creating some little bit of, not critiques, but it's not as rosy as we think, and we need to take a little bit of care. And I know it's out there because I know Jess Morley, for example, works in this field as well with the AI ethics and myself. So a little bit more background from me. I started out, first degree was in clinical biochemistry, master's in medical science, and my PhD was in developing prediction algorithms that would diagnose mutations that cause amyloid formation, which is Parkinson's and Alzheimer's disease. So I come from a biology background, and I've sort of found myself quite surprised in the middle of becoming now a computer science lecturer. But it's from that sort of journey that I started thinking about ethics, because from a bioethics background, that was always something that I thought about, moving into artificial intelligence, and suddenly finding this mysterious field that everybody talked about, AI, and suddenly just going through that process myself and thinking, it's not all that hard. I'll explain why I say that in a minute, and that it's not all that mysterious as we think it is. And I then started looking at how I worry that people trust AI too much and think it is a cure-all. They think it's objective and they think it's highly accurate, and therefore they don't implement it in the right way. So it's really about looking at some of the issues within AI and how, therefore, the solutions are is how we have to think carefully about how we implement that. And I work on IEEE P7003, which is the standard looking at developing, looking at algorithmic bias, and we're introducing, a system as how you do algorithmic impact assessments, which is a strong area of interest for me. So we've seen some great claims today about how we can use artificial intelligence to really cure some of the real problems that we have. And I call these the better than claims. So AI is better than doctors at detecting early breast cancer. That's a recent one. We mentioned about ovarian cancer. And these are really interesting and exciting solutions, which will really, hopefully, people will think that's fantastic. That will make everything easier and we'll spot it. And I'll come back to some of those claims in a little bit in a future slides. And of course, then there's implications, and people start to worry, don't they? Oh, is AI going to come and take our jobs? Are they going to replace doctors? And the answer is oh, no, it's going to augment their decision-making. Don't worry about it. And it's going to be fantastic. But they are the counterclaims that actually is going to actually cause problems within the workforce, and particularly possibly impact on skills. And I will address that in a little bit later, and we can learn from other sectors in that aspect. So there is a whole landscape of argument here that we need to be aware of when we're implementing these new systems, and we don't go skipping along in full of hope and think this is going to be a cure-all. I wish I'd call this slide best practice for predictive and diagnostic algorithms. So I am going to focus on bias, explainability, skills, the issue with skills, and then the idea of training, about how we think about the implementation. And I think this is quite a nice time to mention the code of conduct that the NHS produced. I actually think it's a really good one, and I really like it. And this one is Principle 7. I know after a consultation it got rejigged, so I think this is Principle 7. It was a different one at one point. And it says, show what type of algorithm is being developed or deployed, the ethical examination of how the data is used, how its performance will be validated, and how it will be integrated into health and care provision. Now, I think this is a really important principle, and it covers a huge area. It looks at the issue of data, the data sourcing. It looks at its validation, and this is where we get AI impact assessments, because wherever you use it, it has to be revalidated, and I'll talk about that in a well, and how it will be integrated into their health and care system. And that one is, how is the person actually utilising that, and how are they using it? What sort of system are you putting in place to actually use that AI system? And the people using it, are they knowledgeable about what it is that they're using it? And that comes also to procurement. Do you know what you are procuring, and is it been checked for ethical development and ethical design? Because obviously sometimes the people making the procurement aren't AI specialists. They might not even be clinicians. So do they know the questions to ask to check this out? And I'll give some case studies as we go through to see where there have been some slip-ups. Some of them unconscious, some of them, I will say, are probably deliberate business case decisions. So this is the slide I often use, which is about the stages of human decision-making in designing and implementing systems. So I'm just using a very simple classification system or a prediction algorithm, but recommendation ones can be like that as well. And what we have here is where along this chain of development a human is making a decision and can influence it, and therefore inject into that system all of the biases, conscious or unconscious, accidental or well-meaning, that can actually cause an effect on the outcome, because we have a real issue with algorithms being biased in their outcomes and discriminatory. Right at the very start, we have framing the question, what is the problem we are trying to solve? Why are we trying to solve it? What's our key driver? Is it cost savings or is it quality of care? You know, and being honest about that. And then sourcing that data. Where do we get that data from? And this is a big fight. Every of a data scientist, and all we want is, oh, can I get hold of a data set? We're sort of looking around for data sets all the time. And you have to be really, really careful. They're hot property. I know there's a class action at the moment going on in the States where a hospital has sold its health data, NHS, be listening to this, over to Google. And they anonymize the data set, so they said that's fine. But the argument is, well, yes, but Google has other data on us. And if you match that data with the healthcare data, such as times of hospital visits, for example, you could actually identify it. It's a big challenge, but that is the basis of that class action that's happening now. But where does that data come from? What type of data is it? Where is its geographical location? Is it representative of the population that you are going to actually design your system for? Processing the data, and again, any data scientists in the audience will know, there's a joke that 80% of a data scientist's time is spent cleaning the dirty data, and the other 20% of the time is spent complaining about the 80% of time that they have to spend cleaning the data. But again, this idea that data is not, just because it's big, doesn't mean, just because it's a big quantity, doesn't mean it's quality. And so you have to do lots of decision making as to how you clean it. Do you put in synthetic data? Do you take out incomplete data? And when you pre-process it, you have to sometimes convert information into a system in a way that the algorithm can understand. So if you have a yes and a no, you might have to turn it into a 1 and a 0. Or do you turn it into a 0 and a 1? And that depends upon the stats that you've done and actually the perspective of the question that you're asking. Then we have feature selection. Now, sometimes this can be automated within the algorithm itself, but sometimes you can have an involvement in that. So certainly I did, is what features are going to go into there. And this is where you can start increasing bias. So, you know, again, have you got race? Have you got gender? Have you got postcode? Will that impact on how it will be delivered? And have you got enough females, enough ethnic minorities in that data set to be representative? And people in the issues of algorithmic bias will sometimes say, well, a cure-all to sort out an algorithmic bias is I'll remove the sensitive features. And this is where we hit GDPR about this issue with sensitive features. But actually that could be a bad thing to do. Because if you remove all of the sensitive features, such as gender and sexual orientation and so on and so forth, you can't then test the algorithm necessarily if it is biased afterwards. So sometimes it's better to leave it in. So again, there's a decision-making process around there. Then you have the weightings. Some features are more important than other features, and I'll describe a case study in a second where that became apparent. And again, that can be automated. Sometimes you can actually adjust those weightings yourself. So what value do you place on some of the features? And then, of course, you have the algorithm. And this is the black box. We can't explain the algorithm. It does what it does. It's not our fault if it causes a load of problems. But you actually have to choose the type of algorithm that you're going to use, and it has to be this type that fits the purpose you want. And as somebody who's doing third-year computer science projects, and people come running up to me with a problem, they go, I want to use deep learning to solve this problem. I says, well, deep learning isn't the right solution for that problem, but they want to use deep learning because that's what's trendy at the moment. So you have to choose it carefully. And then this is an interesting point, this exploratory analysis and your metrics, and this isn't reported enough and as accurately. There's an over-reliance on this one. This is where you do things such as threshold setting. So if you're making a classification or a prediction, and you want to say something is likely to be cancerous, something isn't likely to be cancerous, and you're thinking about offsetting your false positives and your false negatives, saying that somebody might have cancer when they don't, and saying that they don't have cancer when they do, which is the greatest risk? At which point do we set our threshold to trade off those with our classification accuracy? And again, statistics are used, but that is a decision-making process. So are people procuring these systems and implementing these systems? Are they knowledgeable about these thresholds? And then deploying and evaluation. How we deploy that, and I've touched on it. Do the people deploying it know about the accuracy? Do they know about the data set? Do they know about the threshold levels? And are they skilled enough to make their judgments without defaulting to the algorithm? And is this algorithm constantly being evaluated? If it's updating on fresh data, if it's been developed in America and you're going to implement it in India, is that applicable? What was the data set trained on? Is it transferable? And again, in IEEE 7003, we're addressing that issue. So in the field of AI ethics, all of those questions raised, it's this whole field of fairness, accountability, transparency, and all of these words are coming up. And so we have now the regulation and governance. We have issues with diversity and inclusion. Well done. There's a challenge talking about that. One of the problems that we have had with bias is that the teams developing these systems are not diverse, and so they don't see these faults. Can you explain the systems? Are they accountable? Who is accountable if something goes wrong? And I will always argue it's the organisation implementing the system. The onus is on you. That is my argument, not on the developer. And in the insurance sector, I went around asking the insurance companies and the developer companies, and they kept on blaming each other and saying, well, it's not my problem, I'm just dealing with the data I'm given. And the insurance companies was going, well, it's not my problem, I'm just dealing with the system that the developers have given me. And it's like nobody's claiming accountability. And looking at AI impact assessments, and this is something that I see as a living document that would actually go with the full life cycle of that system and constantly updated. And with the ICO now are looking at their auditing framework for implementation of AI, and I see those coming fairly soon. And underpinning all of that, we know, and particularly with the pressures on the NHS, you have the business case for using these systems. You have your corporate and social responsibility, and you do have to think about the impact on workforce and skills, particularly within the clinical issues there. So moving quickly on. So I mentioned bias. So a couple of examples were given by Tara about diagnosing skin cancer and moles, and there was some research, and I saw it's one of those better than claims. There is an AI that will recognise skin cancer better than dermatologists. So the dermatologists were saying they were accurate about 87% of the time, and this AI could get it right about 94% of the time. But the question arose, is it accurate on everybody? And there's an issue of whether they diagnose better as well on black skin as it does on white skin. and there was issues about bias there. Now, we know from examples such as Joy Bull and Winnie and Timnit Gebru, who highlighted the problems with facial recognition software, that it couldn't recognise black faces as well as white faces, and it was misclassifying women. And we know from the Google technologists who spotted the fact that photo labelling was labelling black people as gorillas. So bad that they couldn't fix it, so now you can't label gorillas as gorillas because that's the only way they can get out of it. There is a real issue with this, and that's a very in-depth thing. It might not just be the AI, because when you are doing this screening, light travels through black skin differently to as it does to white skin. Same with photo technology. Actually, it was calibrated to white skin. It's not that you can't, a lot of people say, oh yeah, but black skin is difficult to photograph. No, old-fashioned photographic film was calibrated on white skin, so the technology goes a bit deeper than that. So you have to be careful with it. The bed issue. There was an example on in Chicago, and they developed a system where they were trying to estimate who was the likeliest to be stuck in hospital for the longest. And if they could estimate people who are at risk of a long hospital stay, they would fast-track them through the system and make sure that they have priority care. And when they developed the algorithm, they sort of noticed something really odd, and that actually it wasn't highlighting black people were likely to be in hospital longer, but they weren't being given the same level risk scores. So a white person who had sort of less chronic conditions was given the same risk score as a black person. And actually the problem was postcodes. So this is where they said they noticed that people from a certain postcode were being flagged up in a lot more ways, and they investigated a bit deeper. So instead of people from poor backgrounds, and intersectionality meant it tended to be the black community, who have more chronic diseases and more healthcare, they were less likely to get recommended through this priority route than a white person. And that led to a discriminatory output. Unfortunately, they tested it right from the beginning and actually have put in place a system of training to actually address that. So you have to be very careful when you're looking at these solutions. And the black box issue, again, understanding how it is explained. I'm very running out of time, I always do this. There was an image recognition system that was designed to detect hip fractures. Hip fractures can responsible for about 740,000 deaths a year, and it's a real issue. And it combined, they looked at image recognition algorithm on its own, and then they did one that combined patient data and hospital process. And they looked at, and the one that was a combination actually predicted significantly better than the others. And then they didn't believe this black box argument, and they did dig down in it. And there's a whole system now called XAI, explainable AI, things like Lime that you can have a look at and start looking at how the decision-making processes occur. And they found that the key feature, which was more highly weighted than any other, was the age of the patient and the fact that a mobile scanner was used. It didn't really bother that much about the image, even though it was an image recognition system. And if you ask that about the fact that actually a very old patient who's too ill to come into hospital, so you have to take the mobile scanner to them, you sort of already know the answer. You don't need the AI. And it comes back to the clinician system skills there. So again, questions about, do you know the system that you're implementing and understand how it makes its decision? And there are other examples. There's ECG ones that are actually don't, there's a bias between gender, male and female, which surprised me. There's X-ray algorithms that read X-rays to try and detect tuberculosis. Again, showing bias in there, and they don't actually depend that much on the image, and they look at other data where therefore bias can come in. So you again, understanding what you're implementing. So I talked about skills, and skills is a real issue. There are examples of other situations, predictive policing algorithms, and Compass was one for recidivism campaigns. There's a lot of discussion on this, about defaulting to the algorithm and getting that things, and overestimating its accuracy. So the Compass algorithm was used to predict how long somebody would likely to commit another criminal offence and whether they should go to prison or not. And the judges were using it for a sentencing decision. But it's actually only accurate about 70% of the time. It is no more accurate than a simple classifier. So Compass had 137 features, a simple linear regression algorithm with 2 features, criminal, I think, age and criminal record, was just as good. And it was just as good as a bunch of untrained people sat around the table talking about the person. They're not that accurate. And it was biased against black people as well. Knowing that fact, and there was a case brought about it, a class action again on that one, and the recommendation by the judge was actually any judge using this to implement it must understand these facts before they use it. So we can learn from other sectors. So we have skills fade, and this is a big issue within the aviation industry. And I do suggest that people look at the aviation industry. They're actually well up on this. And we've had some plane crashes that have been caused because when the automated system, so this live-by-wire system, for example, that interfaces between the pilot and the sensors and the automatic flying of the plane actually fails in really high-level, stressful situations, pilots aren't skilled enough now to actually adjust and recognise that, and we've had crashes because of it. And if you get the slides, there's some examples of this. And when you look at, you classify a pilot by number of flying hours, but actually the majority of their hours now are spent just on autopilot. And so their skill levels are being reduced. And when they crash, they are often blamed for this. And I call these the humans in the loophole. And very quickly, I want to talk about the child abuse, because you talked about social care. A lot of counsellors are producing these welfare algorithms, which would use as when a phone call comes in to report a problem with potential child abuse or child neglect. It's a screening system that you use to answer all the questions and see, you develop a risk score to say whether you need to investigate further. And these have been introduced into the States, and they have been used as a bit of a deliberate way of reducing and de-skilling the workforce. How can I say it? They are not accurate, about 60% of the time. They have shown to be actually inaccurate in particular cases, particular bias. They are biased against poor families and can be inaccurate as much as 70% of the time in particular individual cases. So you might look at group data, but it's different when you look at individual cases. And the pressure on the social workers and the caseworkers to put in their own information, do their own research, own evaluation, as well as the risk score being generated, and then they get this big red screen with a big number on it saying what the risk score is and what the recommendation is. And it's very hard for them to actually argue against that. And there is evidence that they will default to it because it protects them. It's not me, it's the algorithm. And so they stop, that reduces the decision-making process. And I'm running out of time, but I will say one of the things that's happened is that if you are a less skilled user of these systems, you trust them more. Highly skilled people tend to not trust the algorithm as much. So what has happened is not only have they reduced the workforce in terms of numbers, but they've actually lowered the skill level of the workforce as well, because they found that this algorithm was beginning to train the workers. So as the experienced ones leave or retire, the new ones are coming to be trained up. And I am going to overrun a little bit, I do apologise. They are becoming trained by the algorithm. Remember, this is an algorithm that isn't that accurate and is biased, and it is now defaulting to train them. So again, to be conscious of those problems now in these implementations. And this is one. Just one final slide very quickly. Again, one of these better than claims. These were predicting paediatric illnesses, and in Nature Medicine, better than doctors it was. And actually it's in the algorithm, it's in the abstract, sorry. They've actually said it's as well as experts. And normally they don't make that claim. They're normally very good at it. But this concerned me because it did predict better than physician group 1 and physician group 2. Okay, so 0.885 for the algorithm, until we hit physician group 3, 4, and 5. And it doesn't predict better than them. The difference between those two groups is 1 and 2 are the junior doctors. 3, 4, and 5 are the senior, the consultant level doctors, the experienced doctors. So I had the question of, right, well, how are they going to use that algorithm? And if the junior doctors are using it to train with, will they ever get to be as good as the senior doctors? And I certainly want to go to the person who is in physician group 5 because they got 0.965 right. So whoever they are, I want them. So again, what are you going to use the algorithm for? Is it for training? And meteorologists use them, but they always make their decision first, then check their AI system, and not the other way round. And then they are free to make the decision. So again, think about how you implement them, and the people implementing them understand what they're using. So a closing slide, everybody be relieved. The knowledge is not lost. It lives on in the few remaining specialists and researchers and in a database, which is great. This is historical data we use to train algorithms, but it is no longer being added to, and it might never actually improve. So this is a little warning that we need to be a little bit more careful about how we look at using AI. Some suggestions that we could implement here from training. Undergraduate and professional development on AI-assisted diagnostic and prediction, so people understand what the systems. Require details and decision-making process of the algorithm that you're buying, its performance metrics, its tests for bias and for real-world applicability in your geographical location for your population. That will be in an algorithmic impact assessment. Decision-making autonomy for clinical staff and diagnosing first. And in the welfare algorithms, there was the managers under pressure of the budgets were actually telling the caseworkers who was disagreeing with the algorithm, no, you've got to, the algorithm's right, you've got to do what it says. And they were actually being directed to do what it said. Ongoing evaluation of AI system performance and monitoring for skills fade, and how you would check for that. And again, I would recommend looking at the issues in the aviation sector for help and advice on how they've monitored that. There's quite a lot of research. And I'll leave it there, and thank you for listening. Sorry.
Well, that's certainly turned it on its head, hasn't it? Dr. Gardner, thank you very much. Unfortunately, we have run out of time, so we can't take questions. But let's give Dr. Gardner a huge round of applause, please. I think that was fascinating. Thank you very much.